Managing issues of water, sanitation and hygiene in sub-Saharan Africa is a giant challenge. This is comparatively responsible for the continent's underdevelopment. Like most sub-Saharan African countries, the West African country of Ghana faces serious limits to meeting the challenges of providing adequate and improved water, sanitation and hygiene for its rural and urban inhabitants. A 2018 Journal of Renewable Energy indicates that Ghana's projected population for 2018 is approximately 30 million with a growth rate of 2.39%. This population increase, however, does not happen alone, but with its own issues such as rapid expansion linked with rampant waste generation, which stems from the changing human consumption patterns. Rural-urban migration has been identified for the springing up of the increasing number of informal settlements in the capital Accra. These unplanned communities come with lack of social amenities. Emmanuel Mauli Ablo's review of the triple gains of waste and the way forward for Ghana in the Journal of Renewable Energy says Accra and Kumasi, the largest cities in Ghana, produces about 4,000 tons of waste daily averagely. Inadequate provision of water and sanitation leads to the transmission of pathogens through feces and to a lesser extent urine, exposing children under 5 years to a myriad of health hazards including malaria, diarrhea, bowel ailments, and deaths. Apart from the health risks, poor sanitation causes financial and economic loss to the country. It is estimated that Ghana loses millions of US dollars annually to this. These experts say call for strategies to turn the trend as a way of joining the United Nations to find solutions to the challenges facing the world to meeting universal access to water, sanitation and hygiene issues advocated by the United Nations termed as the Sustainable Development Goals SDGs, a blueprint to achieve a better and more sustainable future for all. Adding to the woes of the continent is climate change, which is affecting all spheres of life.
The £7 million RECIRCULATE project, which is funded by the UK government's Global Challenges Research Fund, aims to drive eco-innovation in sub-Saharan Africa by building capacity for a safer circular water economy. And through this project, Lancaster University is collaborating with researchers from the Council for Scientific and Industrial Research and their own branch campus in Ghana and the University of Benin in Nigeria. The project focuses on the challenges that exist within waste management, energy production, and food security, with the theme of water very much at its core. Now, because of the complexity of the RECIRCULATE project, it requires expertise from many different disciplines, including environmental sciences, engineering, health and medicine, social sciences, and management sciences. Now, when you interrogate the project in a little bit more detail, you'll find that there are 3 interconnected research themes at its core. The first one is water for sanitation, where we explore how we can intervene in managing contaminated water and also other forms of waste to improve and protect human health. And the second theme, water for energy, we look to see how we can take those wastes and convert them to usable forms of energy, with a focus being on anaerobic digestion. And then in the final theme, water for food, we look to see how we can use the waste products from the anaerobic digestion process, taking the water as a source of irrigation and the nutrients that exist within the waste product called digestate as an alternative to conventional fertilizers. Now, the challenges that we're trying to address within RECIRCULATE are enormous, and there is no easy solution. However, some of the generic outcomes that we anticipate from the project are the development of new products, interventions and processes, the continued capacity building elements within research and learning, the development of innovative thinking within stakeholder communities, and of course, ensuring that we continue to collaborate into the future on new exciting research projects?
RECIRCULATE is an interdisciplinary waste-focused research intended to ensure eco-innovation and also to improve collaboration among researchers from various African research institutions and universities and that of Europe. It focuses primarily on changing the definition of waste. One of the major concentration of our study has been on measuring the communicable diseases that we have in the community, especially for children under 3 years. And for this reason, we have mapped out all the households and tracking the progress of the reduction of communicable diseases in Begbese and Madina Zongo.
Exactly what does a safe circular water economy involve?
In 1933, a very famous economist, Zimmerman, defined resources as not fixed things, but as things that human beings could use in order to achieve a particular want or service. So that definition was succinctly captured by Ali Mazrui when he said that resources are not, but they become. So what we consider as resource may not necessarily be the flamboyant things as gold, silver, diamond, crude oil, and all those things. But it could also include what we consider not too desirable, like waste, water, fecal matter, and all those other materials which we consider unwanted. But once you add technology to it, you could use it for profit. And this definition underpins the United Nations Sustainable Development Goals, which looks at the 4 R's in material management. That we should look at reduce, reuse, recycle, and recover. So for the safe water economy, we are considering water as a resource and how best we can reduce its use for a particular activity without necessarily, stopping or preventing efficient use. Then we could also consider how we could reuse water, recycle water, and also recover what we consider wastewater for economic good. So that is what the RECIRCULATE project is all about, driving eco-innovation in Africa in the safe water economy. So we are looking at how we could use innovative tools and technology and science to see how best we can reduce the water that we use in agriculture, which constitutes about 70% of water usage, and also how we could reuse some water which we use in our everyday activity for hygiene purposes, how best we could reuse it, recover some of the nutrients that could be locked up in some of this wastewater for agricultural productivity to be enhanced. Water is life, they put it. So the RECIRCULATE project is much wider than AGRIC, which forms the integral part of Work Package 3, that is water for food. But also it is about health. So in Work Package 2, we are looking at how best we could manage sanitation and proper administration of water in order to reduce the morbidity that is associated with bad or bad quality water. So we are looking at how best to reduce pathogens and its transference into potable water. We are also looking at how we could harness energy from water and to be used for productive use. And the reason why water is so important is that it forms the basis of life. And any economy that is circled around water becomes very sustainable in that you need it in order to be able to live. And if you use it well, it means that the chances of we having a more environmentally friendly technology which will not emit any greenhouse gases which would harm the environment in future. It's very high. So that is how come our focus mainly is on the water economy and how best we can use water.
These wastes are either thrown into open dams, wetlands, landfills, and uncontrolled dumps, or, in some cases, are incinerated in the open air. With these methods in use, an insignificant quantity of waste generated ends up in recycling or composting units for reuse. Amidst the untapped potentials in waste, properly managed and fully exploited, they would provide a good quality of life for Ghanaians through energy generation, employment creation, income acquisition, and resource for goods production, among many others. Two communities, Begbeise and Madina Zongo, in the national capital, serves as the case study.
Initially, when we entered the community, we noticed that the community has a lot of broken down pipes which are crisscrossing most of these drains. And we know that microorganisms can enter these pipelines through these drains. So we have observed that the pipelines are not properly constructed within this catchment area where we are doing the work. And RECIRCULATE is going to fix all these pipelines as an intervention. RECIRCULATE is also going to make sure that people empty their toilets, their septic tanks at regular intervals to prevent leakages into these drains. It is these leakages into these drains that contaminate the drinking water. So RECIRCULATE is going to address those issues, and then the education that we undertake within these communities will help the people to be able to maintain their storage facilities, clean their water before they drink their water from their sources. So I think these are some of the benefits that the community will get from the work that we are doing in these two communities. The project also has done a lot of education within these communities. And this education is geared towards changing the attitude of the community members in terms of how they use water, in terms of how sanitation generally is managed within the community. And this will go a long way to reduce the cholera and diarrhea cases within these communities. The weather station is very key to this project because we know that rainfall affects the behavior of people in these communities. And people normally throw in their waste into their drains when there are rainfalls. And the weather station in the communities is going to give us the data of the pattern of rainfall within the time that we are doing the research in the community. So it will help us interpret the data that will generate from the quality analysis of the drinking water, so that we can actually predict when throwing of garbages and fecal material into these drains happen.
So we're doing daily measurements. And then we realized that, in fact, we started around 6:30 to about 11. So each time we come, we do the measurements within this time. And then we noticed that around 9 o'clock, that was when we had a peak or the highest flow, which means it was the time materials are released into the water body. So we are looking at two things here: the flow measurements as well as the sampling for lab analysis. So each time we come here, we pick the samples for lab analysis, and then we do the flow measurement here. Basically, the flow is the amount of fluid that passes through, let's say, a water body in a second. So we are looking at how material is released from the community into the drain. So that's what we have. We empty one sachet of this to 1 liter bottle. Okay. So we are going to release the concentrated salt solution and then see how long it will travel from one end to the other. So we have our stopwatch here. Okay. And then once the salt solution is released, we start the timing. Okay. And then know the time that it will take for the conductivity measurement to read or change. because we've noted down the initial reading. I hope you are getting me. Okay, so Afia, you can release. Okay. Should I go? Okay. Yeah. Yeah, start the time. So we know the difference when the temperature changes. Stop. Okay. So you have 26.32 seconds. Apart from the physical parameters that we measure, we also do other chemical tests, like the BOD, that's a biochemical oxygen demand. I will explain. Then the COD, that's the chemical oxygen demand. These are indicators of pollution or contamination. Good. Now, these are parameters that we measure routinely. And the EPA has got some set guidelines. So normally, when we measure them, we compare with the EPA guidelines to see whether they are exceeding or they are within. If they are exceeding, then we know that the values are above the threshold and something must be done. If they are not exceeding, then well, that is good for us because, as I said, the water eventually gets into the streams and then the sea. So far, the values we are getting for the BOD and the COD are quite high. They exceed the EPA guidelines for wastewater discharge. But there's one thing that the project hopes to achieve. Good. Now, the project in the long run wants to see that the incidence of diarrhea is reduced in children under 5 years. There are going to be interventions. For instance, the broken down latrines are going to be repaired. We also see some bare PVC pipes. All these things are going to be repaired because when they are exposed, then the drinking water is going to be contaminated from their wastewater. So all these things are going to be put into proper shape. And we hope to also measure the drinking water from the households for a period. And then, as I said, eventually I want to see that the incidence of diarrhea is reduced because we are going to liaise with the hospitals to also know the hospital records, whether they are recording more cases of diarrhea or rather the incidence is going down. So eventually, these are what we are targeting at.
We first of all engage the community in a community entry activity by saying the opinion leaders of the community, the chiefs of the community, and the elders of the community. We came to see them to ask permission to work with them. And this activity took on with all the team leads in working together with the social science lead. And we came to introduce ourselves, had meetings with them, and they agreed for us to work in the community. And the second activity we had was household listing. The whole community was extensively mapped by using a drone to capture the whole area view of the community by house to house. And we mapped them in blocks. All water points were mapped, all toilets were mapped, and then households were mapped to various toilet points and water points that they fetch. So the household listing, we asked a few questions of the community members by asking them where they actually fetch water, which toilet point they use, and this was used to map every household to a particular water and toilet. And then this one will help us to do the water journey and then water drinking sampling. When the water sampling is taken, we'll follow them from water journey 1, where the water enters the community, then up to where they fetch the water to their households. And then the water will be followed to the various households to test their drinking water to see how their water fares. And also, we are doing diarrhea monitoring in the community to measure the diarrhea incidence in the community by using children under 3 years. So we visit these children under 3 years every 2 weeks for 24 months. That one we started before intervention. And it continues through intervention and then after intervention. This one will help us to know whether our intervention has had an effect on the diarrhea incidence in the community and other illness. We have involved the community in many ways, especially the members and the leaders. We had a focus group discussions, which we call participatory appraisal, to engage them to mention every problem they have in the community, including water they use, the problem they have with their water, sanitation issues, and institutions that serve the community. So this is what we did during the participatory appraisal, which we involved males, females, and youth groups that we engaged them in an extensive discussion. And then we also went on to in-depth interviews. As a few members of the community were randomly selected, and they were interviewed on how the community is, and then their experiences within the community. This one also will help us to augment the survey data that we collected. All the activities were done in both Begbese and Madina. Madina is our control community where there will be no intervention. The intervention will take place only in Begbese. Then Madina will be the control community, which will study the two, and at the end of the project, we'll be able to tell whether the intervention has had an effect on the community. Therefore, we had appraisals both in Begbese, we had appraisals both in Madina. And then we'll also take drinking water sampling before intervention, during intervention, and after intervention. And the diarrhea illness monitoring is also being run throughout to the end of the project to measure the incidence. And Madina, we also have the studies, the in-depth interviews there. We have the diarrhea monitoring there, and we also had participatory appraisal to also involve the community members within Madina Zungu.
Over the past few months, we've been mapping out all the toilet and water facilities at Begbese, looking at the drains and how best we can improve upon it. Currently, we are doing toilet user monitoring to know the number of people who use specific toilets and what could be done to improve upon those facilities. After the initial water sampling, we'll then start the actual cleanup of the drains, repair of the drains and the toilets and taps. After that, we'll go further ahead of ourselves to get a girls group formed, which we are starting with the initial training to get those young ladies to speak to the community about their hygiene, about basic hygiene, about hand washing, about them keeping their homes and their communities clean.
The CSIR Water Research Institute is involved in the water for sanitation and health, as well as water for crop production. In fact, it looks as if you have transported a rural area into an urban setting. So because of this, their life is faced with a lot of challenges that are related to health. For instance, they have challenges with safe and potable drinking water, and then the kind of crop production that they are engaged in. So it is for this reason that Water Research Institute is involved in the water for sanitation and health. So what Water Research is doing in this area is to look at all the various water resources in these communities, and as I indicated, there's always the challenge of what is the quality of the water. So Water Research is involved in monitoring the water quality in these places and also looking at the sanitation. Now you realize that when the sanitation of the place is very poor, it impinges on the health of the people. So what Water Research is doing is to make sure that what is the quality of the water, and then in addition, where there are challenges, there are interventions that will be put in place to ensure that the lives of these people are improved. They are monitoring the water right from the source of production to their homes. And then the purpose is to look at what is the cause of contamination of the water along the chain system. So what happened is that right at the beginning where the water is produced, they assess the quality of the water, and then just before the water enters the community, the quality of the water is assessed, and then as it gets to the homes, we also assess the quality of the water. And now once the quality of the water is assessed, we'll be able to know where the challenge of contamination is.
All these are meant to reverse the current trend of poor water, sanitation and hygiene situation in unplanned communities in urban centers and raising economic levels of the urban poor. Food sufficiency is high on the agenda of the project, with special interest in maize and rice.
Ghana has a huge import bill for tomato
and then rice. So we are helping in that direction so that we'll be able to produce enough of rice and tomato to augment those that are being produced locally. And in so doing, will help government to cut down the importation. So our scientists have come out with a lot of technologies in the area of water management efficiency and nutrient management efficiency. We are also not trying to compromise with the environment. And at the same time, one will ask, is water limited to us? It depends on the way you look at it. Water is unlimited. That means we have to find efficient use of water as one of our resources. Come to think of it, our scientists have developed technology in such a way that they save a lot of water in the production of these two commodities. That is, the water that they are using to produce these commodities, they go about it in such a way that at the end of the day, a lot of water is being saved. So what we are saying is that these scientists have done very well. And then all the technologies that they have developed, they have popularized it to a lot of people, and other stakeholders are buying into these technologies that they have developed.
What we are doing is to explore the various technologies that will help us manage nutrients and water under this crop production. So we have set up 2 demonstration trials, one on rice and then one on tomato. Under the rice demonstration trial, we are exploring opportunities of managing water and nutrients using the alternating wetting and drying technology, what we call AWD. AWD is a technology that only requires that you water when the water table or your instrument in the plot indicates that the crop requires water. So we are doing this alongside what farmers do, which we call continuous flooding. So there are several factors in this demonstration trial. We have the different irrigation types, which is the AWD versus continuous flooding type. Then we are using this under different crop varieties. We have improved rice variety, which is an improved rice that is released by crop research called Agra rice. Then we have a local rice variety called Vienna short. So we have 2 rice varieties under this demonstration trial.
We also have research ongoing on tomato. Currently what we are doing on tomato, we call it the partial root zone drying, PRD. What PRD essentially means is to irrigate a crop but only half the root zone area. So you are only irrigating 1/2 of the crop root zone, the crop's root zone. And we are doing this using the furrow irrigation technique. The furrow irrigation technique is a technology, an irrigation technology whereby we plant on ridges and irrigate or pump the water into furrows to irrigate the crop. What we are currently doing, we have tried several furrow irrigation techniques. We tried the fixed furrow irrigation technique for the partial root zone drying, and we have also tried the alternate furrow irrigation. The fixed furrow irrigation is this technology or technique whereby you only irrigate one of the furrows. You know, every bed or ridge has 2 furrows, one on the right, one on the left. So if you choose to irrigate the one on the right, that is the furrow that is going to receive all the irrigation water for the rest of the growing season or growth of the crop. So that is the fixed furrow irrigation. And then the alternate furrow irrigation is whereby you switch between the 2 furrows. So at every irrigation event, if the first event you irrigated the first furrow, the second event, you switch to the next furrow. So one of the furrows receive water at every irrigation event, not both. And then we did the conventional ones where our farmers irrigate both. So we see in all these cases, for example, the alternate furrow irrigation, we are saving 50% of our irrigation water. And it's the same with the fixed furrow irrigation. So what we are doing currently is we have tested these three irrigation technologies alongside what our farmers usually do. Now we are going a step further to introduce nutrient sources. We have the organic and the inorganic nutrient sources vis-a-vis these irrigation technologies. So in the first, let me talk briefly about the initial results that we had. The initial results suggested that the fixed furrow irrigation was performing better. We were not having any significant yield losses alongside what we used as the control. So we have taken out this fixed furrow irrigation and is testing it further using these two nutrient sources. So the two nutrient sources, we have the organic source, which is the digestates, and then the inorganic, which is also the NPK fertilizers that our farmers usually use.
Work Package 3 is presently cropping maize. Maize because for some time now, Ghanaians have been using maize as a staple. Everywhere you go in the country, it is maize, it is maize, it is maize. And because of climate change issues, we've also realized that there is the need for us to improve water consumption. Therefore, the decision has been taken, because the emphasis on this particular work package is on partial root zone irrigation. We are looking at dry season cropping. But in Ghana, we've also realized that a lot of people undertake maize production during rainy season. And so the decision to undertake this is to help improve, that is, if this project becomes successful, for us to be able to enhance dry season cropping of maize. And this, we think, will go a long way to improve crop production or food production in Ghana. We have realized that for some time now, climate change is actually having an effect on agriculture production in the country. And because this is an irrigation project, we are looking at instances where we can improve the soil moisture availability of maize even during the dry season. And so the emphasis is on dry season cropping, which, if it should go well, will let us have enough water during the dry season. The idea is not the quantity, but at least making cropping maize with minimal water to improve crop production. So that is where the emphasis on.
It is different from what they have been seeing and what they have been doing. They see this as a new hope in the sense that they will save money, because if successfully carried out, they will save money on water supply, and for that matter, production costs will go down and profits will rise. Because compared to the continuous flooding, where energy is used, in some places diesel, they spend more on energy. But the AWD doesn't go that way. So from their visits, they have seen that the continuous flooded fields and then the AWD, there is no much difference, or there is no difference at all in plant vigor. So they have a new hope that they will make more profits if they are using less money on water supply. Secondly, looking at the technical aspect of it, because of climate change, the reservoirs, the dams, the duckouts are not able to accumulate enough water. So the little water that the duckouts, the ponds, the dams will accumulate, because of the AWD intervention, minimum water will be used for optimum yield.
Most important on the table for consideration is leafy vegetables.
Looking at the type of vegetables we produce here, a lot of them are the leafy types, and they require a higher source of nitrogen. Last year or last 2 years, we did a basic experiment to compare the two operations, and then we realized that the organic operations did better. We got better yields from our fields compared to the inorganic. So it's our aim as a company to fully move on to the organic type of vegetable production. Others will argue that the inorganic sources are cheaper, but vegetable production has its own requirements. The inorganics on the market are usually blanket fertilizers. They don't give a higher level of nitrogen in the blend. Those specialized ones are hard to get and very expensive. So it would be best to depend on the organics. In the short term, they complain it's very expensive, but then when you compare the results in the end, in the long run, you realize it's cheaper because it gives you another advantage of improved soil structure and texture.
We are doing anaerobic digestion. Anaerobic digestion is it's a system where you put sewage or nutrients, organic nutrients into the system, and then it would digest it. At the end of it all, it will come out with the liquid part and then the solid part. But with research and with trials, we found out that the liquid part is good for crops because it has a lot of nutrients in it. And anaerobic because it's doing everything without oxygen. That's why it's anaerobic. So we want to use that effluent or the liquid part of the digestion to cultivate crops. And on this one, we are going to focus on cabbages. So this is the field where we'll be doing the cultivation. And we are going to do it in parts because we need to compare with the current and then the proposed one we want to do. So we are going to have a control that will have no fertilizer, nothing. Then we are going to have one with a solely chemical fertilizer. And then we'll have one with the anaerobic digestion, the effluent from the anaerobic digestion on that part. Then we'll have a mixture of the anaerobic digestion effluent and then the chemical fertilizer. So we are going to have 4 different plots, and then we'll monitor, we'll do the micro, we'll do the soil test before we start, and then we'll do the nutrient test of the anaerobic digestion effluent, and then we'll do the cultivation till cropping and then harvest, and we'll do our yield analysis and other scientific experiments on it, and then we would compare the results. We chose cabbage because it's a bit tougher, if I should use the word, and it's able to withstand a lot of environmental conditions. Tomatoes, sometimes if you are not careful, you could have it going wrong along the line, but we need something that can withstand the soil, can withstand external factors and all that. And this place being our farmland, we've done cabbage over here for a couple of years now, so I'm so confident and so sure that cabbage will do the job for us. That's why we chose cabbage. It's becoming day by day expensive using the chemical fertilizers, and especially in terms of the environment, it's not the best for us because it's creating a lot of issues. So we want to use this experiment to educate our farmers that it is time we move into the organics. It's safer, you have more yield, you have better quality, and you have value for your money.
Irrigation scheduling, when properly harnessed, will be the game changer in this era of climate change and beyond.
One of the major challenges with research is how the beneficiaries of the research or the stakeholders are going to benefit from our research findings. With this project, what we are looking at is I'm going to engage a lot of farmers. As part of the work package 3 activities, we've done various social entries or community entries as well as social research, whereby we've interacted with farmers. So as part of our research work, one of the key thematic areas is to organize open days for them. We have already conducted a stakeholder seminar. Additionally, what we are going to do is that we are going to also create documentaries that will serve as a teaching material in their local language, that are going to organize demonstration plots in their various fields, that the outcome of the results over here will be made available to the farmers, and they'll be trained in using the various technologies as well, so that at the end of the day, after the project has ended, the farmers can take the project over.
When all these interventions and innovations are successful, we look forward to
we're looking at the end of this project to come up with innovations which will be ready for the market to help boost our agricultural production.
At the national level, definitely this will feed into the health outcomes of the national level, where our health burdens in terms of the monies that we spent on treating people with cholera and diarrhea cases will reduce. And if those cases get reduced, then it means that those women will also now have time to do their work, because sometimes they have to take their children to hospital all the time. But if they don't take their children to hospital, now they have a quality time to go and do their job, and these children too will be healthy and attend school.
One may ask, how does the Ghana government benefit from all this, or Africa benefit from this research? The research is community focused. It deals with waste, and there are three key important things that we stand to benefit from this at the end of the project. The first is the reduction in the communicable diseases in the country. The second is the reduction of the importation of pharmaceuticals that will otherwise be used in treating malaria, cholera, and others. And then, by extension, this will lead to good health for the community and for the people, and by extension, from Ghana to all other African countries. And that we sincerely believe that this is the model that every government should adopt in solving the waste menace.
Considering the current water, sanitation and hygiene handling situation in Ghana and the pushy targets of the Sustainable Goals 6, which aims to ensure clean water and sanitation, Goal 8, decent work and economic growth, Goal 11, sustainable cities and communities, Goal 12, responsible consumption, and Goal 13, climate action for all by 2030, there is the need to discover the stimuluses behind them if the unbendable targets of the Sustainable Development Goals, SDGs, are to be attained by 2030. Strangely, Ghana, and for that matter Africa, has not been able to translate its quantum of waste generated over the years into processed forms that could be utilized for productive purposes for energy generation, wealth creation, wealth generation, and resource for production that could boost its emerging economic transition from subsistence agrarian economy to an industrialized and service-oriented economy. And this is what this collaboration seeks to achieve. This is where the RECIRCULATE project fits in perfectly in turning around issues of water, sanitation and hygiene in Ghana, and by extension Africa, for economic empowerment and development.